So yesterday we were doing the duet CB40 FM walkie-talkie, which, as you know, I still need to put a battery compartment holder in, which is on order. So we can't do a field test until that's arrived. Now, the whole idea about buying that set of 4 radios from Knight's Clearance Corner was to get this Danita 285. And sadly, we don't have an aerial. And it's quite a long aerial, and it does indeed have an SO239. We've got a picture somewhere. I've got a picture on file, haven't I? Yeah, I've got a picture on file. I mean, that looks like an afterthought. It looks like somebody's put that in instead of a telescopic. I'll go and get the pictures off the file. So because it wasn't a model I was ever aware of till I saw this for sale on eBay, this is the thing. So doing a search, not really much, but this is somebody selling a pair in Germany, and you can see they have a longer than normal telescopic aerial. This mag mount, we tried an Intec one, which was kind of a cellular lookalike, and it was so dire our analyzer can't see it on any frequency. And so I bought another one. Obviously I like spending money on things which are useless, and it's exactly the same, and I bought it from a different source. It wasn't out of the same batch. So I don't know what that was about. It presented a stupid SWR, and of course, as you can expect, the range is half a mile. So I would think that magnetic aerial works worse than I was going to say telescopic. It's a rubber duck type of thing, but they are longer than normal. A bit like we're presented with those Ranger 6, the PE project ones. So, you know, to do a field test, I need those aerials. So any field test we tried with the wrong aerial would be disingenuous, wouldn't it? So that's a difficult situation. Obviously we've not got the carrying cases. And just to back that up further, I found this picture of somebody selling one at some point. Not this, you could tell it isn't this particular one. This one's got a nice dent in it, and it was advertised with a nice dent in it. So and you can see it's got the SO239 on the top. So I'm satisfied that isn't something that somebody's done. Sometimes I have to research these things like that. I'm going to open it up because it comes as, obviously it's come from their clearance thing, so it's sold as a scrap radio. And as I said before, this isn't some kind of they couldn't fix it and I can. I don't know that I can anyway, but you've got to remember that you spend 2 hours on something like this and it's an uneconomic repair. So unless you can do these kind of things in 40 minutes, it's not worth doing them commercially. And the other thing is, nobody's going to want to buy a CPT only. And we've got it's the 10-1, which is what it should be, in beautiful condition. Looks like it's been replaced. So you've got the option here that you can put an 8-pack if you're using throwaway batteries, or a 10-pack if you're using rechargeable batteries. So once again, the maths behind that is 1.5 volts times 8 is 12, and rechargeable batteries 1.2 volts. You need 10 of those to also make 12. So that's your that's the maths behind it. So if you're going to use throwaway batteries, we would use an 8-pack, as it says. So this has been put in for rechargeable use. So that's a nice start. At least it's got the battery holder, or one of the battery holders. That's in nice condition. Looks strikingly like the Kaiser radio from the 80s. Another of those ones sold as 2 watts, which is half a watt. Or was it sold as 4 watts and it was 2 watts? Something like that. This looks new. Okay, that pillar isn't. Crystal filters. So I brought along with me the notes for the Kaiser. Yeah, it's nothing like. So it might look similar, nothing like. There's no circuit diagram. So, here's an interesting thing. It's TC9109. So it's the Toshiba synthesizer. I wasn't expecting that. I'm only assuming that that's not supposed to have a core in it. So we're going to have to fumble our way through this. They're going to be VCO. Clearly these are receive. I'm expecting that's a transmit strip. And they're the goodness knows what. USB 595. Not a transistor I'm familiar with. Aye, but is this the output transistor and that one's the regulator transistor? Yeah, 2SC2078. So that's the output transistor, that's the regulator transistor. That looks to be the FM chip. No, it's not, because what have we here? That's the FM chip. This must be the speech processor. I'll tell you what, this is a fiberglass board. And considering this is 1980s, that's expensive at the time. So let's see what we can do. Power. So just like yesterday, it's going to be 12 volts. We're not going to run it more than 12.8. This time we've got an earphone socket. This makes all the difference between tuning it and using it, not having to faff about taking the board out to get access to the speaker. So that is brilliant. You've got display so that it's momentarily on, which is good. And it says it's battery, RF and signal. So that's, again, we've got a set with a signal meter. And then it's got high-low power, not because it's a legal requirement, but to save on your battery. And because it has an SO239 on the top, of course it doesn't have to have an external aerial socket, because that's your external aerial socket. So far, so good. Now, does it work, or can we get it to work, is the next question. So we'll connect it to test gear. Remember, this is CEPT only. I have no idea whether this is positive or centre negative, so we're going to start with positive, and we're going to have the power supply on a 300 milliamp current limit. At 12 volts. So far so good. No short. Current limiting. We'll try the polarity the other way around, just like yesterday's set. That's better, 65 milliamp. If we press the display illuminate button, we've got a display. That's a good start. We're in high position. Right, we better change the current limit. Change that to 1.2 amps. There we go. So our channel 20 is going to be 27.205. Let's put picture in picture on select camera 2. We're on a road trip to Worksop today on business. So I'll take one of the vintage camcorders with me. But it's receiving. That's 1 microwatt. Not good at all. Okay. At least it proves the synthesizer's working. We're going to transmit. Where's transmit? Interesting, it just shut down. Does it have a dodgy push to talk switch? Well, it does now. Not necessarily broken. Let's get it turned off. Back on. Now we've got transmit. Out of the box it's doing 2.8 watts. And we can look at the band edges on this one. You can also put the squelch on. Channel 1, 2.8 watts. Channel 40, 2.7 watts. Go back to channel 20. Our current consumption is 712 milliamps. Low power. Is 700 milliwatts, 690 milliwatts. Deviation, see if we can tune it in. Wallow. Shows us 2 point right over the lead, 2.2 it shows that. We won't be doing the VCO. We're struggling to know anything about this set without that. 27.205.07. Set's not warmed up yet. 27.205.07. That's brilliant. And the RF meter. Are we on low power? We are. The RF meter showing 3.5. And the S meter, if we put S9 signal on, isn't showing anything. All I can do is put very low. If I put the full whack of the signal generator on, which is 10 millivolts, it's reading S5. But at least it's there and it's working. It doesn't have a meter lamp. Yes, 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 doesn't have that. It's those are those. So it's now the receiver's turn. So let's connect it up to the test gear through the earphone socket. Switch the cyanide meter on. Switch over to that. It's a working set, isn't it? It needed the PTT doing it needs a service. And the other set in the batch is a Battered Realistic 1002. They work well but not versatile. You don't need an earth, it's getting its earth. Squelch down. So at the moment it's 2.5. .3, and if it does 20, tell you what it does, it's 4.5. Squelch, threshold. Was flawed because I'd not got the signal generator on standby. There's 1 microvolt and full squelch is 24 microvolts, so it's not a bad squelch range for a walkie-talkie. So there we are, we've got a set which is working, needs a service. We've got to work that out. Shall we waggle it over the other way? Doesn't matter what I do, it looks like it's the wrong way. Don't know whether there's some electronics under there. Just the microphone. So we don't know whether that should have a core in it. Or we can try it with the core and see what happens. So it looks to me like our transmit strip is those. We can soon see that, and if I get it wrong it doesn't matter, because we can put it back. So 2.8 watts. See what happens when we turn that one. Absolutely nothing. That's a broken core. Hardly dare touch these. So none of those have got it to. None of those have got it to transmit better. So I'm going to just see whether they're affecting the receive. You know, I wouldn't expect that. I'd expect them to be transmit. But I've certainly made it deafer, so there we are. Definitely receive. Yep. I think that was the broken one. I'm not sure what we're going to do about that. I mean, at the end of the day, that's 1 microvolt. What I don't want to do is to start taking the board out and unsoldering that and breaking the coil, which we can't replace. So I don't know. Well, so that turned out to be a receiver. So those two are the transmit, because these are the IF part of the receiver. See what those are. So go back to transmit. Yes. So that's the early stage of the transmitter. Both of those are absolutely spot on. So the only other transmitter adjustment is here. Absolutely peak. So have we got a core in a scrap set? It looks like that type, doesn't it? So if we've got chances of having one. I'm always saddened by this Mustang 1000 scraps, 3000. Disgraceful that somebody did this to it. That's been left because it's actually broken. Just wait for the soldering iron to warm up. Whilst that happens, we'll go back to the receiver. We'll have a look at the IF. See a test point there. Not that we're going to do that. So I think that's the frequency trimmer. Let's go to the frequency counter. Nearly. Oh, look at that. That's one thing done. Back to cyanide meter. Put a bit more signal on, about there. See if there's anything we can do with these IFs. That's correct. That's correct. That's our detector. So do that with this S9 signal with the oscilloscope. And sufficient volume. Turn it down a bit. Back to a lower signal and turn the squelch off. That was clever, I changed the channel. Now they're having no effect, so are these a transmitter? Back to transmitter. They're not the type normally associated with transmitters. No, don't affect the transmitter, so it must affect the receiver. Right. Possibly there. Right, see whether we can recover this. Got my soldering iron lead caught up with the bracket. See whether we can recover this. And whether it makes a transmit difference. Now when you can't reference against another radio, it's all guesswork. Back to transmit. No, it's not the right thread. I'm going to take this out. Yes, finer thread. I'm going to go into transmit without that. So we've now got much lower power. I'm just going to put it in this one and see whether it alters things. Now, if you see there, it makes no difference. So I don't think it's supposed to have one in. What we may have got is high and low power on these presets, because we seem to have got a regulated power supply. We have, and it's at full power. I'm not showing you the right meter. So back into transmit. We've got 2.8 watts. If I adjust that preset I just did and turn it down but not up. So I'm now assuming the other one is low power. So I've switched to low power. Yes, it does indeed adjust it. I'll tell you what we're going to do. I'm going to set it to 400 milliwatts, just like we would on a UK set. That gives us a nice comparison. I've no idea what it's supposed to be. Obviously not 400 milliwatts. But it is now. So it's still 2.8 watts. So have we got an S meter adjustment is the next question. So we've got an adjustment there, an adjustment there, an adjustment there. So I'd expect this one to be deviation. So I'll tell you what we'll do, we'll put the thingy on. And see whether that adjustment, which is off camera, it is, that's deviation. I'll go to the test set behind me. And set the deviation accurately. It's about where it should be, to be honest. Just pick it up and do a while. While it's 2.4. I'm not going to adjust that again. So today the Marconi test set's telling us the truth. So it was 2.2, now 2.4. So we've got a preset here. That is the squelch control. So chances are, if I advance the squelch right on the edge, I bet this affects it. On the other hand, it doesn't. Okay. Let's put 100 microvolts on and see whether it affects the meter. No. Well, it's not going to affect it in transmit because it's nowhere near that part of the circuit. Okay. See whether one of these presets is transmit meter or receive meter even. Try that one. That's not doing anything. That's not doing anything. Okay. But that's transmit meter. So I think that is receive meter, that lower one. So let's put a bigger signal on. Something's affected it because it's not reading anything. It's that one. So I put 100 microvolts on. Let's see whether we can get 100 microvolts. No. Well, I'm now intrigued, so no, it's definitely not meter. So that's at full whack. Let's just check where our transmit meter is. That's still in the same position. So our rather lazy meter reads 2.8 millivolts, which is better than the 20 millivolts it was doing before. So I can't see how that's related anywhere in the circuitry, but is that the squelch? Nope. I've got absolutely no idea. So I've got receive meter, transmit meter, high power, low power, deviation. I'd expect squelch, but the circuit is around here, so that because of that I was expecting that to be near the squelch control and therefore to be the squelch preset, but it isn't. No, I don't know. Anyway, it's the position it's at and the radio's working. That just leaves us, is there any way we can move this broken core? I'll go to off camera and see. Right, I'll rejoin it with you as we're coming to the top. I managed to break out the bits that are causing the wedges between using two metal screwdrivers to help break it further. I managed to get it to the top. Just about get that with my fingers. There we go. Now there's not enough to turn around and put the other way. See what we can recover out of a scrap set. as long as the thread's the same. These are Taco branded, so top brand. Let's make sure we've got the cyanide meter on. No, that's not the right type. Right, there's a Billy No Mates coil, so we'll try a Billy No Mates core out of it. I think that's not going to fit either. Nope. Right, we'll abandon the Maxon idea. An illegal AM walkie-talkie of GRE origin. And it's a blue coil, as this is a blue coil, which seemingly looks like the same coil. That fits. There's another American piece of crap, you see, which is useful here. Well, all that tells me is that where it was broken was the right point. So just make sure we're not going to gain anything anywhere else. Still not sure what these do. So for 12 dB, better hold on to it. Might make a difference. No, it's not good. It's 1.65. And 1.45. $20 dB is now 2.8. Squelch. Maximum. Is now 10, 11, 12, 13. A minimum. .78. That still reads 3.5. That reads 2.8. You never know, might come up against one of these with an instruction book. Perhaps somebody has got a instruction book, or they've got a circuit diagram which would help. I mean, these to me look like they're part of the IF, but they're not making much difference. And we've got a query with that preset. But other than that, we've got an improvement. Let's look at where our transmit power is. I've now got low power at 400 milliwatts. So on channel 20, transmit, and I can find the PTT bar, is 2.8 watts. Channel 40, well it's 1 now, is 2.75 watts. Channel 40 is 2.75 watts. I've got that balanced a little bit better. Our transmit current 732 milliamps. So there we go. I mean, I think this is a nicely made set. We've got a broken, snapped off pillar. You know, I could find another one, couldn't I? We'll also just put it back loose. It's my set at the end of the day. So we'll put that back together. If I can remember where I put the case. So I went to all that trouble, spent about 20 minutes doing that, and it was actually made no difference. But you've got to check these things. It's no good just saying, well, it'll do. So I'll screw that back first so it doesn't get lost in the works. We'll be able to do a field test on this set. But what do we use as an aerial? Because it's the aerial that's key to the range. I'll clip that back on there and then nothing's going to short out. There we are. Right, we'll swap it now for the aerial, turn the test gear off. Switch picture in picture off. One on a Roger. One for a Roger. I bet he's not on 4 watts. There we go. Never seen one before, Danita 285. So, is there a date code? It's probably about 1987. And it's PR27GB, it's not a grey import, it's the real thing. Thanks for watching. Made in Japan.